Back in episode number 20, we were taking a look at how the DNS sinkhole technology and concept can be used to perhaps do some malware spoofing and prevent fast flux attacks, things of that sort, in addition to being able to contain an infection by limiting the ability for that malware to connect back to command and control servers. Also, in episodes previous to that, we talked about the effort or the effect of the WPAD and the way that we could intercept doing man-in-the-middle attacks simply by changing our NetBIOS name to be WPAD. And that particular attack we talked about in a Windows context, but I did tell you in that episode that it is not just a Windows issue. So in this issue, we're actually going to combine those two different episodes and talk about how WPAD can be used in combination with the DNS sinkhole or spoofer in order to accomplish a man-in-the-middle attack against pretty much any browser on any operating system that might be using the WPAD feature. Now, to get set up, first of all, I've got the backtrack system running in the background here, and on this system I have Burp Intruder already running, and it's got a proxy listening. I've also already taken the time to create all of the necessary pieces for our Apache setup. Now, if you look back at that previous episode, you'll see the discussion of the WPAD file, which I've included here, the wpad.dat. And that's the file that, if you remember, contains this very simple JavaScript function, find proxy for URL. And in this case, I have it configured to refer back to this machine, 10.0.173, on port 10080, or, I'm sorry, not 10,080, 1080. And that is, of course, where Burp Intruder is listening right now. Now in this window right here, I'm actually going to start up a sniffer, and I'm going to ask the sniffer to listen for things on port 53 so that if we want to, we have an opportunity to come back and see what kind of DNS queries are happening and see the responses that our spoofer is generating. Now as you can see right now, I can continue browsing around, refreshing pages, and there's no interception happening here in my Burp Intruder. Well, I'm going to quit out of Safari, and let's come back over here into our Linux system where we have the DNS spoofer and see how it's configured. Now, right now, in the /etc/DNS block directory, I have all of the required files. In the allowed sites, that one is actually blank. The blocked names file is also blank at the moment, but the blocked strings file contains only the letters WPAD, because I'm looking to intercept WPAD. Now, why wouldn't I put out something more specific here? Well, when the systems go to do their DNS resolution, they will likely be attaching whatever their default DNS name is. So for instance, let's say we were at a Starbucks and it assigned us an address locally, and it may give us a default DNS domain. Let's say atnthotspot.com, something like that. So when my system goes out and tries to find WPAD, it's not going to look for just WPAD. It will be wpad.atnthotspot.com or something like that. So by using the blocked strings, I can catch all of those and not have to reconfigure this for every site that I might be at in trying to do this demonstration. I've also set the blocked web address to be the local system. So in terms of reconfiguration, what would be necessary for someone to actually launch this attack? Really just two things. They would need to identify what their IP address is. We found that with ifconfig after we were part of the network here. And then simply to modify the wpad.dat file and the block web address to be 10.0.173. With that out of the way, I'm ready to start up DNS block. And I'm not going to bother putting it in the background. I'll just run it right here. And now let me go into my network configuration. I think I may have that up. Oh, I do. And I'm going to go into the advanced configuration here. Now I happen to be doing this on a Mac, but this will also work on a Linux system, a Solaris system, pretty much anything that's going to run something like Safari or Opera or Firefox, anything that will support Automatic Proxy Discovery. So as soon as I turn that on and click OK, and then I'll apply those settings and close up this configuration panel. I'll now start up. Oh, and already look what's happening. We can see that there are already attempts to connect to this localhost machine trying to do something with WPAD. Now, I'm not going to concern myself too much with that right now. Instead, I'll just start up Safari. And Safari does work, but note when I come over here, I can now see the requests going into Google immediately. So Burp Suite is already intercepting the requests. Now I'm going to stop this because Macs do go a little bit crazy trying to go out and find the local start of authority record. But if I scroll back up here, let's see if I can find where it actually sent the first WPAD request. It might be quite a long way up. Actually, it might have scrolled off the screen already. Let's just see here. I can see it trying to do those resolutions. Well, probably a more efficient thing to do would be to just push this off into a file and then just grep through it and find that WPAD query. Yet, if we were to find it, what we would discover is, and I can actually simulate one, let me start this back up again, and I'm going to change it a little bit. Let me tell it to look for port 53 and host 10.0.1.73. That's this host here. Oh, and there's actually a lot of queries there too. The reason for that is that I believe I still have Safari running, and it's attempting to do queries now through this system, through the proxy itself. So I'll stop that. I'll come on over here and put the DNS blocker in the background. And let me try to ping WPAD.com. Just give that as an example. And you'll see that I'm getting this answer now from 10.0.1.73. But if we look at the DNS queries that went out, we can see the question going out here to 1011 to WPAD.com, trying to find that. And we can find that 10.0.1.1 sent back a, oh, this here, that means there is no answer. But in fact, it actually had already received the answer from the local machine with a spoofed reply. It would have been better to look at this as a reply coming back to my Mac, because, and actually I can simulate that as well. Let me force that to happen here. Let me tell this to go ahead and just watch port 53 again. We're still going to have to fight with those start of authority records. Sorry about that. And let me start up the terminal, bring it down into the window here, and I will just try to ping wpad.att.net. How about that? And I'll stop this right away. And we can see here that I've got the query that goes out. This is the one going from that Mac, trying to hit that host, or trying to hit the local DNS server. I then find immediately after that a response just a few fractions of a second later. This is an authoritative response giving the answer of 10.0.1.73. And then after that, I see the bad response coming back later, much later, almost half a quarter or an eighth of a second later. I see the failed response coming back from the actual DNS server. So because of positioning, we're able to intercept and respond to these queries before the host gets the real answer from the server. Now, could this be detected on a network? Well, certainly. You might look for things like UDP port unreachables coming out of your DNS as a result of DNS responses coming back. There would be other signs too, in addition to being able to or notice that in your DNS cache, suddenly you've got a lot of hosts resolving down to just one. So that would be a sign as well. In terms of DNS poisoning, I prefer this particular method because in poisoning a DNS server, you're actually attacking the server. But just by doing this here, we are poisoning the cache of a server by simply returning bad authoritative answers. This is much, much easier to do, provided we can find the correct positioning. Also, we're coupling it again with that WPAD attack, remembering that that special name, the Web Proxy Auto Discovery Protocol uses, will be not just a NetBIOS name that's available, but also a DNS lookup name that we can use to leverage this type of attack. This episode, of course, is a little less on the auditing side, but it does give us a good reason to understand why we'd want to have that WPAD entry set up in our local DNS server. For example, here, if we were to run this test multiple times, we would find that if I try to look up wpad.private or wpad.local, the local DNS server will actually answer that question faster than the spoofer. and will come back saying that there is no such address. So if we were to actually populate that with an address, we do run a good chance, depending on positioning, that our own DNS server could answer faster. Or again, the other defense, if we're talking about a road warrior type system and being concerned that if we're in a library or a Starbucks or a McDonald's or an airport, could someone be running this attack against us? The answer is of course they could, but recall that we said if you simply create an entry in your local hosts records. So for instance, we're saying that if we were to go into the etc hosts file and simply add in an entry saying that 127.0.0.1 is going to be WPAD, when I try to ping WPAD now, it will always go to 127.0.0.1. The difficulty might be the added-on domain name, so if it tried to do something specific, it would not catch that. But it should try that WPAD name without a qualified domain name first. If it succeeds at that, it will not progress to other ones. So that could prove to be a defense for us as well. So in terms of auditing, those are some things that we might look at if we were really concerned about man-in-the-middle attacks with any kind of web or proxy manipulation that could be happening out in public places, as well as, of course, things that could be done on our local network within our environment.